You just have to forgive me for the way this question works. I know it is a bit skewed and so on, but I'm trying to save time. I'm trying to do these questions as fast as I can, okay? But anyway, stories. Let's take a look at 5.1. Write down the value of P. So what are we dealing with here? We have f of x, which is equals to a divided by x plus p plus q, right? And then in order for us to find I have to think about this, to find the vertical asymptote, we have to say that x plus p is equals to 0. So x is equals to minus p. This is how we find the vertical asymptote. Okay, so let's take a look at our graph and see if we can determine our asymptotes. We can see the vertical asymptote here, that x is equals to 1. That is the vertical asymptote. So what does that tell us? This tells us that when x is equals to 1, we have the vertical asymptote. Okay, we're back in business. X is equals to 1. So it should be easy to see that p is equals to minus 1. But let's see if this brings us back to the vertical asymptote being equals to 1. So we would have x minus 1 being equals to 0, x is equals to 1. So it's easy to see that indeed the vertical asymptote is equals to indeed p is equals to minus 1. Okay, and then 5.2, determine the equation of the horizontal asymptote. Determine the equation of the horizontal asymptote. The horizontal asymptote, we are looking for the value of q. That is the horizontal asymptote. Q is right here. We are looking for q. That is the horizontal asymptote. So how are we going to do that? We don't have f of x, right? And then we don't have any number that is given close to the vertical asymptote, like we were given in the vertical close to the horizontal asymptote, just as we were given on the vertical asymptote. So how are we going to do that? Well, we are going to use the equation of the line of symmetry, right? We know that g of x is equals to x minus 3. Okay, g of x is equals to x minus 3. And our asymptotes p and q. P and q, they meet at not p but minus p. Minus p and q. Minus p and q. We know fully well that they meet right here at that point. They meet on the line of symmetry. So we can actually substitute the value of p in order to find the value of q, because the value of p is going to be our x and the value of q is going to be y. So we have q being what we're interested in, and then in place of x we have 1, right, minus p, minus 3. So q is equals to minus 2, right? So we can conclude here and say that our horizontal asymptote, we have y being equals to minus 2. This is what you need. Y is equals to minus 2, not q is equals to minus 2. I've seen this get marked wrong, right? On I think it was the prelim in Gauteng. So, you're not supposed to end with q is equals to minus 2. You're actually supposed to go further and say y is equals to minus 2. We are not looking for the value of q. We're looking for the equation of the horizontal asymptote. Y is equals to minus 2. So there we go. Right, very basic things, but with just a bit of a twist, really. Yeah, they're very basic, but there's a twist. So I would expect this question to throw some people off. But anyway, stories. Let's take a look at 5.3. So 5.3, we are looking for the value of a, right? We know that f of x is equals to a divided by x plus p plus q. We're looking for a. We have p and q, so let's just sub them in our equation. F of x is equals to a divided by x plus p. So x, p is minus 1. So x minus 1, and then q is minus 2, and then minus 2, right? And then x minus 1 is equal to 0, x is equal to 1, so we have the asymptote there. Okay, I was just checking if I'm substituting them in the correct way. So this is f of x as we have it. We need to substitute a point into f of x so that we can find the value of a. That's what I'm thinking. There might be another approach, but that's what I'm thinking. So let's see if we have a point here. Do we have a point we can substitute into f of x? Let's take a look. There has to be something we can substitute here. The graph of f casts the x-axis, or not the x but the y-axis at 0 and 1. So okay, we know that this point lies on f of x, so we can substitute it. In place of y we have 1, right? And then in place, let me see, in place of a, that's what we're looking for. In place of x we have 0, right? I thought x is minus 1. Issues were gonna arise there. I was not quite happy with that. So a divided by 0 minus 1 minus 2. So we have 1 being equals to a minus 1 minus 2. We take minus 2 to the left hand side, we get 3 is equals to a divided by minus 1, a is equals to minus 3. I think we can just end it there. A is equals to minus 3. But let's just go ahead and see if it makes sense. A is minus 3, x minus 1 minus 2, I think. X minus 1 minus 2. So let's substitute 0 and see if we get 1. Yeah, when we substitute 0, we get 1. So I'm quite convinced that that is the correct value of a. And then 5.4, for which values of x is f of x greater or equals to 0. So let's take a look at this wing here. When we take a look at that wing, f of x greater or equals to 0. Well, it is less than there. It is less than. It is less than. Because that is below the x-axis, right? Because we have the x-axis right here. So that wing is below the x-axis. So it cannot be part of our solution because it is always negative up to infinity. Okay. And then let's look at this other wing. The other wing, well, when does it become positive? We need to find values for which it becomes positive. Is that easy to find? We just know here that we have 0 and 1. So it becomes positive somewhere here, right? That's where it becomes positive. But we don't have the x value at that point. So I think we I think that we need to actually find the value of x for which it becomes it starts becoming positive, right? So how are we gonna do that? Well, what is the value of x when y is equals to 0? Okay, so that's the question. Let's take a look. F of x, we need it to be equals to 0. So we have 0 being equals to minus 3 divided by x minus 1 minus 2. So 2 is equals to minus 3 divided by x minus 1. Okay, so 2x minus 2 is equals to minus 3. So 2x is equals to minus 1. So x is equals to minus 1 over 2. So the value of x here at this point where it starts becoming positive is minus 1 over 2. So from minus 1 over 2 up until x gets very close to positive 1, our condition is satisfied, right? Our graph is gonna be greater than 0. Is that what we're looking for? Yeah, we're looking for the values of x for which f of x is greater than 0. So we need x to be, it says greater or equals to, so we can include minus 1 over 2, but we cannot include 1 because it is not defined at 1, right? We just get very close to 1, but it is actually not defined. So why am I using a bra and not a cat? We're supposed to write this one. Okay, so there we go. That is 5.4. And then what about 5.5? What about 5.5? I'll let you guys talk about it in the comments. What about 5.5? What about 5.5? I want to hear what you guys think. But ultimately, describe a possible transformation that f could have undergone to result in h. What is the characteristic of h? The domain and range of h are the same as that of f. Okay, and then h prime of x, the derivative of h is negative on its domain. So what is the possible transformation? Let me know in the comments. But should I give the answer? Okay, I have the answer in front of me, but I feel like if I give the answer, then it is no longer fun. So I'll let you guys talk about it in the comments. And then, after a couple of comments, 20, 30 comments. Yeah, give me 30 comments. And then I will sort of give you the answer to 5.5. Yeah, there we go. Which question do we do next? We've done 1 to 6. Do we just do 7, 8, 9, 10, 11, 12? Let me know in the comments.